So hello friends, welcome to my new video. So today in this video I will discuss with you all about a very important topic that you all should know as an optometrist, that is about refractive diagnosis. So I should upload this video earlier, but now I am uploading this video. So refractive diagnosis means by seeing the refractive error you are able to tell that which type of refractive error the patient is having. That's called as refractive diagnosis. Okay. So here let's start from the simple hypermetropia. So simple hypermetropia means I want to tell you that uh, if this is the cornea, then it is having both vertical and horizontal meridian. Okay. So if the power distribution in this vertical as well as horizontal meridian are quite equal, then the refraction is called as spherical refraction. That means there is no multiple focusing point. So suppose this is your eyeball, and here these are the parallel rays hitting the cornea after refraction. If get focus behind the retina, that is called as hypermetropia. So if all right rate gets focused on only single point behind the retina, that is called as simple hypermetropia. So simple hypermetropia, if I give you the example of simple hypermetropia, then it will be like uh, here plus 3 diopter spherical. So this is the example of simple hypermetropia. Plus 3, plus 2, plus 1, plus 5 diopter spherical. These are the examples of simple hypermetropia. If I give you the example of simple myopia, so what is myopia? Where the parallel rays of light after which are coming from infinity after getting refracted by cornea and lens get focused in front of the retina. So that is called a simple myopia. So the example of simple myopia is -1 diopter spherical, right? Or -2 diopter spherical. Okay, so this is simple myopia, right? That's very simple. Okay, so this is simple myopia. Okay, so simple hypermetropia example: plus 3, plus 2, plus 5 diopter spherical, and simple myopia -1, -2, -3, -4. Okay, now I told you about the simple myopia and hypermetropia, but there is another type of refractive error is there. So that is astigmatism. So what happened in astigmatism? That, as I told you earlier, that suppose this is your cornea. Okay, so this is your cornea. Then it is having two principal meridian, right? So this principal meridian, vertical meridian and horizontal meridian. Okay, so astigmatism is two type: regular astigmatism and irregular astigmatism. So regular astigmatism means the axis is, it can be 90-degree or 180-degree. That is called as regular astigmatism. Okay, and what is irregular astigmatism? Irregular astigmatism means the axis can be like that, where one axis can be 60-degree, another can be 30-degree, but their addition will be 90-degree. So that is irregular astigmatism. Okay, so here so let's say about the regular astigmatism, where there is two type, that is known as with the rule astigmatism and against the rule astigmatism. So what is with the rule astigmatism? So in case of with the rule astigmatism, so this vertical corneal curvature is more steeper than this horizontal corneal curvature. So if I give you the example of with the rule astigmatism, then it will be like -3 diopter cylinder at 180-degree. Okay, so this is with the examples of with the rule astigmatism. So why 180-degree? Because when you will place this -3 diopter cylinder at 180-degree meridian, in this meridian, okay, then what will happen, that the power will get distributed in this meridian. Okay, in this meridian power will get distributed because you are placing the cylindrical you are placing the cylindrical meridian in this axis, right? So in, you know very well that cylindrical axis not having any power, but the power distributed to the opposite meridian, so power will get distributed to this meridian and the astigmatism will get corrected. So this is how you will correct a case of with the rule astigmatism. So if I write this in plus cylinder form, then it will be what it will be, like minus 3 plus 3 at 90 degree. So this is the form of with the rule astigmatism. Okay, so in case of with the rule astigmatism, minus cylinder will be at 90 degree and plus cylinder will be at minus cylinder will be at 180 degree and plus cylinder will be at 90 degree. Okay, and in case of against the rule astigmatism, it will be opposite to with the rule astigmatism. So here the minus cylinder will be like minus 3 cylinder at 90 degree. Okay, 3 diopter cylinder at 90 degree axis. That means your axis in this meridian, so power will get distributed to this meridian. Okay, so this is how you need to write it down. Okay, so suppose I want to give you the example that because there is a types, right, that the astigmatism can be simple myopic astigmatism or astigmatism simple hypermetropic astigmatism. So how simple myopic astigmatism look like? So here as you know already that in astigmatism there is two focusing point is there because of the asymmetry in the two principal meridian. So light rays are not getting focus in the same meridian, so one light ray getting focus in this and another is getting focus to this meridian. So there is two focusing point is there, so you need to correct it by spherocylindrical lenses. So suppose this is the eyeball. Okay, so here suppose this is a parallel rays of light coming from infinity after getting refraction at cornea and lens. One light is getting focus on the retina. Okay, so that's very okay, but another light ray get focus behind the retina. Okay, so so this light ray is getting focus on the retina, it's very normal, but this is abnormal because it is getting focus behind the retina, so it is hypermetropia. So this type of refractive error will be called as simple hypermetropic astigmatism. So how to write, what is the example for simple hypermetropic astigmatism? Let's give you the example. So simple hypermetropic astigmatism will be like plus 3 at 90, 90, 180, 60, any axis can be there. Just the thing is that only plus 3 diopter cylinder at 90 degree. Okay, that is the example of simple hypermetropic astigmatism where the spherical value is plano but the cylindrical value is there at specific point, so that is known as simple hypermetropic astigmatism. Now let's say about the simple myopic astigmatism where so parallel rays of light, one light ray getting focus on the retina but another light ray get focus in front of the retina. So if light ray get focus in front of the retina, it is called as myopia. So it is an example of myopia and you will write simple myopic astigmatism. So what is the example for that? The example is very easy. So the example will be minus 1 at 90 degree. So this is the example of simple myopic astigmatism. Okay, now let's go to more complex form. Okay, so suppose one light is getting focus in front of the retina, another light also get focus in front of the retina after some distance. Okay, so here you can see two focusing point are there, f1, f2. Okay, so two focusing point are there in front of the retina, that means it is known as compound myopic astigmatism. That means there is two focusing point are there in front of the retina. So here, what is the example for that? Example is -2 with -1 at 90 degree. So that is the example for compound myopic astigmatism. Okay. Now let's say about another thing. Okay. So here, so that is I given the example of compound myopic astigmatism. So what will be the condition when one light is getting focused in this position and another light also get focused behind the retina? So it is an example of what? Compound hypermetropic astigmatism. Okay. So what is the example for that? Example is very easy. That is +3 with +1 at 180 degree. So there is example of compound hypermetropic astigmatism. Okay, so this is how you need to do the refractive diagnosis properly. I am giving you the examples as well so that it will be easy for you to understand it properly. Okay, so now take us another example. Okay, so here light rays, one light ray getting focused in front of the retina, another light ray get focused behind the retina. So it is called as mixed astigmatism. Okay, so it is called as mixed astigmatism. So how to write the mixed astigmatism example? Example will be +2 with +5 at 90 degree. Okay, so here if so apparently it look like that compound hypermetropic astigmatism, but you need to do transposition of that. So when you will do transposition, it will be look like +7 with -5 at 180 degree. Okay, so here, okay, wait, because it is showing quite haphazard, right? So here let's give you the example of mixed astigmatism. What I given you here, +2 +5 at 90 degree. Okay, so here if I do transposition of that, then it will be +7 -5 at 180 degree. So you can see both plus and minus. You can see this plus and minus sign is there. Okay, so it is indicating that light rays are getting focus in front and back also. So whenever please remember this thing very nicely, that if you see the cylindrical value is more than the spherical value, always it will be a mixed astigmatism. Okay, but if you see the spherical value is more than the cylindrical value, then it will be always, what to say, compound type of astigmatism. So for better understanding, I will give you one example of compound myopic astigmatism also. So let's give you the example. So here I'm giving you the example of +2 with -1 at 90 degree. So if I do transposition of that, then it will be like +1 with +1 at 180 degree. So you can see even after the sign are plus and minus, after doing transposition both are in plus, so it is saying that compound hypermetropic astigmatism. So it will be compound hypermetropic astigmatism. So this is how you need to do refractive diagnosis, where you can see that the spherical value, so this spherical value is more than the cylindrical value. Okay, so this spherical value is more than the cylindrical value, so that's why it is always what to say, compound type of astigmatism. But when you will see the cylindrical value is more than the spherical value, then it always mixed type of astigmatism. Okay, so here I also want to give you another example of mixed astigmatism. So that is +3 with -5 at 90. So it is definitely, it is a mixed astigmatism by seeing this. But then also if you do the transposition, then also the both plus sign will not come, it will be only plus and minus. Like here -2 with +5 at 180 degree. So you can see that you cannot even match the sign properly if the cylindrical value is higher than the spherical value. So that's why remember this thing, it is a case of mixed astigmatism. So this is how you need to diagnose, or you need to do the refractive diagnosis properly. So apply this thing in your clinical life also, so that it will be helpful for you to do better practice in your clinical. For thank you so much for kind listening, and I will upload the next video very soon. Okay, thank you so much.